Question, est-ce que le soutenance sera en anglais ou français?
En anglais.
Ok, d'accord. Donc l'ouverture sera en anglais. بسم الله الرحمن الرحيم. Ça va, ça smooth? تمام. بسم الله الرحمن الرحيم. Ladies and gentlemen, dear colleagues, as the president of this jury, I am honored to open this PhD defense session. Today we are gathered to assist the doctoral thesis of Ms. Hamdi Inez, entitled Ecoethology of Breeding Anatidae and Phenocopteridae in Algeria, Stationing, Phenology and Ecosystem Descriptors, supervised by Professor Bara from the University of Guelma and Professor Garcia Perez from the University of Elche, Spain, and examined by three specialists, Professor Gerge Bellemin from the University of Gherdaya, and Dr. Ramdani and Dr. Yonsi from the University of Guelma. I have the privilege to present this jury as Professor Berlush. Ms. Ines Hamdi, you have 30 minutes to present a main point of your research. Please feel free to begin.
Thank you so much. So, ladies and gentlemen, esteemed jury members, friends and family members. So, ladies and gentlemen, esteemed jury members, dear friends and colleagues, thank you for being here today for the defense of my doctoral dissertation entitled Ecoethology of Breeding Anatidae and Phenocopteridae in Algeria, Stationing, Phenology and Ecosystem Descriptors, under the supervision of Professor Muslim Bara and Professor Garcia Perez Juan Manuel from University of Elche in Spain, who unfortunately couldn't be here with us today but is assisting via Google Meet. So before I begin, I would like to express my warm thanks to my jury and the advisors, Ms. Bagnish Afef, Mr. Yunsi, Mr. Girgib, and Mr. Domdani for their support and their guidance throughout this journey. So, here's the structure of my presentation. I will start with an introduction, then we will move on to the overview of Anatidae and Phenocopteridae in Algeria. Then I will present the study sites, the objectives, and the methodology adopted. The core of my presentation will be dedicated to the results and discussion. Then it will be which will be followed by conclusions and recommendations. So wetlands are globally vital ecosystems, serving as biodiversity reservoirs and providing key services such as water regulations, pollution filtering, and support for human activities like fishing, farming, and tourism. The Mediterranean wetlands are rich in biodiversity, especially in North Africa. Wetlands in Algeria, they serve as key stopovers for Palearctic migrants. With the 50 Ramsar sites, the region's highest, Algeria holds major global ecological significance. These wetlands act as vital stopover sites as refuges for migratory birds crossing the Sahara Desert. The key locations include El Qala wetlands and Lake Fazara in the northeast, and Lake El Golia as Ramsar sites in the Sahara Central, a crucial link between the Western Palearctic and the Afrotropical regions for waterfall. We will move on to the Anatidae in Algeria, an overview. So the family of swans is represented by three species of swans: the mute swan, the bewick swan, and mover swan. These three species are rare species, observed only once or twice in Algeria. Secondly, we move on to the geese. Only the grey-like goose is a wintering species in Mikada Marsh and Lake Fazara. The other two, greater white-fronted goose and the Egyptian goose, are rare species observed only once or twice in the Algerian wetlands. Thirdly, we move on to the shell ducks. The shell ducks family is represented by two species, the common shell duck and the ruddy shell duck. Both of them are very abundant species. sedentary breeding birds in the highlands and in Sahara. So, yes, fourthly, we'll continue with the Dublin ducks. From this large diversity, we will concentrate only on the mallard duck, which is a very abundant species, sedentary breeding bird in all Algerian wetlands, especially in the highlands, and the Algerian population is estimated between 5,000 and 7,000 individuals. Continuing with the double ducks, we will focus on the marble teal, which is a sedentary species nesting in the wetlands of the highlands and Sahara. It is classified on the IUCN Red List. Lastly, we will move on to the diving ducks. From this diversity, we will focus on the ferruginous duck, which is a sedentary species nested in coastal areas, highlands, and Sahara. The wintering population is estimated between 1,000 and 1,000.2 individuals. From this population, the main concentration of this duck is found in the coastal area with between 70 and 72%. In the highlands, only 5 to 8% of the population, and in Sahara, only 1%. Continuing with the diving ducks, we will focus on the white-headed duck, which is a sedentary species nesting in wetlands, mainly in coastal areas. The Algerian population is estimated for about 300 pairs. Lastly, we will move on to the Phoenicopteridae in Algeria, which is where we found only the greater flamingo, which is a breeding species in the highlands and in Sahara. Lesser flamingo, which is a rare species and observed only once in the Algerian wetlands. So from this large diversity, I targeted only 5 breeding species for eco-ethological study. So firstly, we have greater flamingo, which has a least concern IUCN status. The mallard, which also has a least concern status. The ferruginous duck, which has near threat status. The white-headed duck, which has an endangered status, and the marble teal, which has a vulnerable status. So, the main objectives were to understand the ecology and behavior of these species. Secondly, to analyze their phenology and spatiotemporal distribution. Thirdly, to assess the influence of abiotic factors on distribution of these species. And finally, to provide data for targeted conservation and management strategies. So the study was conducted in 15 sites. 4 of them were non-Ramsar sites, which are Sabkhat Oulad Amara, Bulgara Dam, Shot Gaday, and Poussadamar, and 11 Ramsar wetlands, which are Lake Tonga, Lake Bilwazou, Mikada Marsh, Garat Hash Tahar, Lake Fizara, Lake Bugazul, Shot Al Hadna, Garat Timirganin, Shot Umarana, Lake Golia, and finally Bazar Seka. These are two pictures taken during our outings. Three main methodological axes were adopted. So the first one was for the census and phenology. So we did monthly counts from September 2021 to August 2023. For the diurnal behavior study, we used instantaneous scan sampling, observing these activities, following activities. So we followed the feeding, sleeping, swimming, preening, flying, parade, and antagonist behavior for every day for an hour between 8 a.m. and 4 p.m. As for the abiotic descriptors, so physical, chemical, and bacteriological parameters of wetlands were measured systematically. So for the physical, chemical parameters, we used multi-parameter HANA HI 98194. For the mineralization parameters, we counted them according to Rodier method and all. And for chemical parameters, we used colorimetric and spectrophotometric method. For the bacteriological parameters, so for the count of total germ, we did a plate count method. For the research and identification of fecal contamination, we did an MPN test. And for the research and identification of pathogenic germs, we isolating them using selective medium. So now I will move to the result, the part of my discussion, my study. So, for the greater flamingo, it was studied in two wetlands in Sahara, which are Lake Golia and Chott Omarene, for a duration of from 2021 to 2022. So, the first figure represents population trends for the greater flamingo from 2021 to 2022 in two wetlands, where we can see that the difference between these wetlands are in numbers. So, numbers peaked at 7,500 individuals at Chott Omarene during December, and 1,100 individuals in El Gouria. So, as for the second figure, so the Gaussian shell-shaped seasonal curve, the rapid increase from September to December, a peak in January, and a gradual decline to August matches the species' known migratory pattern, and there's a significance in number between these two wetlands, as we can see in this figure. So, due to their gregarious nature, flamingos often congregate in areas away from disturbance. At Lake Golia, this wader occupies the center of the lake, especially in shallow areas. At Chott Omarene, early in the morning, flamingos spread out over the entire stretch of body of water, forming more or less distinct group. However, during the day, these water birds will move to closer to the road near the main sewer that feeds the Saharan wetland. So, as for the assessment of the diurnal activity rhythms, we noticed that feeding was the main activity in both wetlands. And during the study year at Chott Omarene, so over here, flamingos spent most of their daytime feeding, especially during arrivals and transits, with activity highest at the beginning. Walking is linked to feeding or disturbance, was frequent from October to December. Grooming occurred briefly in the morning, while sleeping and courtship were equally present. Sleeping mainly in early winter to recover from courtship from December to July. In small water group, flying was rare, limited to site changes or predator avoidance. So, the multivariate analysis of greater flamingo at Chott Omarene shows that feeding was the dominant activity central in the data, with flying minimal and separated from other activities. Sleeping and grooming are distinct from walking and courtship, with a clear temporal pattern. So, feeding and flight in September, sleeping and grooming in October, from October to December, and courtship with walking from January to April, linked to breeding preparation. Secondly, we move to the mallard, which was studied in Lake Tonga for 3 consecutive years from 2020 to 2023. So, over 3 years of the study, the highest mallard numbers were recorded in December or November each year, with lows in June and complete absence in July and August due to drought. So, the lack of significant variation suggests that lake environmental conditions are homogeneous, allowing mallard to distribute evenly over the congregate in microhabitats, in specific microhabitats. So, moving on to the activities. So, monitoring the mallard activities at Lake Tonga over 3 years showed feeding as the main activity, sleeping and swimming were next, followed by plunge maintenance and grooming, while flying was minimal. This indicates that Lake Tonga is an important diurnal feeding sites for the mallard. Now we move to the yearly follow-ups. So, During the second year, the Malars at Lake Tonga spent over 40% of their daytime feeding, mostly from November onward, with similar patterns for the first year and the last year. During the early in the season, from September to October, they focused more on plumage maintenance and swimming due to post-migration recovery and disturbances. Sleeping was the second most common activity with peaks in spring and September. Swimming remained highest in September and October. Grooming accounted for about 7 to 9%, mainly among early arrivals. Flying was minimal, less than 1%, also triggered by disturbance. So, for the animal trans activities for the monarch in Lake Tonga, as we can see, feeding was more important in the second year. Sleeping was also important in the second year. Grooming was relatively stable throughout the year. Swimming was more important. Swimming and flying were more important throughout the first year. So, the multivariate analysis at Lake Tonga identified 3 distinct periods. So in September, Mallard showed intense swimming to form groups. In October, they focused more on plumage maintenance and short flights to regroup after migration. And from November to June, feeding and sleeping dominate, highlighting Lake Tonga as a key feeding and resting site for wintering and breeding species. Thirdly, we move on to the ferruginous stock, which was studied in 5 coastal areas that are Lake Tonga, like this was Wogat, Hashtar, Lake Fizara, and Nikadamar for a period of 2 years from 2021 to 2023. So, the population monitoring over 2 years showed regular presence of ferruginous duck at 5 sites, with numbers rising from September. Peak population occurred between October and February, especially in December, reaching up to 790 individuals at various sites. Now we move on to the spatio-temporal distribution. The species consists of 2 distinct populations. So a larger one, overwintering groups that occupies quiet, deep, and undisturbed sites, and a smaller one, sedentary breeding group found in heliophyte-rich areas. This breeding population usually travels alone in small groups. In larger sites like Lake Fizara and Nikadamash, only the groups near the banks were observed. So, during the study year, the ferruginous duck mainly spent their daytime sleeping across the 5 sites. Feeding was the second most common activity, followed by swimming and grooming. Flight, courtship, and antagonist behavior were minimal, each accounted for about 1 to 2% of the main activities. The monthly diurnal activity of ferruginous duck varied across 5 sites, with sleeping increased from September to peak in January, then stabilizing. Feeding remained steady year-round, slightly dropping around February. Swimming was consistent, except for lower levels in January to March. Grooming occurred daily, but was lowest in January. Flying happened mainly due to disturbances or running away from predators and poachers. Parading and antagonism were rare, apparent only from March onward with low weights. For the multivariate analysis of ferruginous duck, the temperatures at Lake Tonga and Garat Hashtahar revealed similar animal activity patterns. So, flight characterized early in winter from August to September, followed by dominant sleep and swimming during winter from November to March. Courtship and antagonist behavior peak around March and April, while feeding and plumage maintenance occurred from May to July. Moving on to the white-headed duck, which was studied in 5 highland wetlands: Garat Timurgania, Garat Ulada Marash, Kulhodna, Bugarada, and Bugizunda, for a period of from 2020 to 2022. So, in the first year, the white-headed duck numbers varied widely across all sites. peaking in January at Garat Timerganin, May at Garat Walad Amara, and Shot al-Hudna, in April at Bugazul and Bugara Dam. So reflecting pre-mating and pre-migratory aggregation periods. The second year experienced severe drought, leading to very low numbers at most sites, with only Bugara hosting relatively large numbers in October, from October to November, before a sharp decline due to low rainfall. So, in these 5 wetlands, the white-headed duck occupied the deepest part of the water body. Generally, we observe groups and pairs of this diving duck in the center of these water hydro systems. These places, far from any kind of disturbances, seem to offer peace and quiet and good food availability. During the wintering season, the white-headed duck is activities were mostly dominated by resting or sleeping, ranging from 39 to 53% across most sites, except at Bugara Dam, where feeding was the main activity. Swimming is the second most common activity at most sites, but ranks third at Bugara Dam. Feeding is third at other sites, while grooming accounted for 80 to 40%. 40%. Disturbance-related flying behaviors are low. So the white-headed duck spent most of their daytime sleeping at 4 sites, conserving energy in winter. Feeding was steady year-round, rising from June with reproduction and molting, and was dominant at Bugara Dam. Swimming was most common as an escape or group activity, while breeding peaked in winter for feather care. Flying was rare, usually related to disturbance or predator-driven. So, the factorial correspondence analysis of the white-headed duck activity at Garat Timerganin and Bugara Dam revealed 3 distinct seasonal periods. So, at Garat Timerganin, from September to October is marked by arrival and sleeping combined with flying and grooming. From November to April features intense swimming and group formation for nesting. From May to August show increased feeding to prepare for breeding. At Bugara Dam, the second figure, from September to December is dominated by sleeping for energy recovery after migration. January to May centers on feeding for breeding preparation. As for the last period, from June to August, has fewer birds engaging in grooming and flying due to low water levels. Moving on to the last species, which is the marble teal. The marble teal was studied at Shot Moranab at Pilaya of Urgla for 3 consecutive years, from 2020 to 2020. So, monitoring the marble teal at Shot Moranab showed regular presence, with number peaking in October each year, around 240 individuals, before gradually decline. These species include both a local breeding population and a migratory group, using the site as a stopover during the migration to Sahara and highlands, wetlands for wintering and breeding. The highest number were noted during the third year of the monitoring. As for the population trend, follow a bell-shaped curve with significant variation between 3 years and months, highlighting the importance of these wetlands for the species conservation. So, the gregarious marble teal gather mainly in the center of the lake, in small islands of the Shot, areas that provide peace and protection for these species, away from disturbance. As winter progresses and water level rises, these numbers increase, expanding into the northern and central lake sectors. So, over 3 wintering seasons at Shot Moranab, the marble teal's main diurnal activity was feeding, supporting energy needs for juveniles and breeding preparations. Sleeping ranked second, mainly occurring in water. Swimming followed, observed mostly midday by individuals moving away from groups. Grooming varied between mostly in water, while while feeding was minimal, usually triggered by predators or contagious flies from other species of birds. These species generally favor daytime feeding, unlike the population studied in Morocco and Spain, where feeding was mainly nocturnal. So, across 3 winters, marble teal fed with peaks in February, which means post-migration recovery, and April, which means pre-migration and breeding, and sleeping was the second activity, highest in numbers, and lowest in April. Swimming peaked from December to January, linked to feeding and grouping. Grooming rose seasonally after molting, while flying was rare, slightly increasing over years and tied to arrival and grouping. So, sleeping, swimming, and feeding were relatively stable throughout 3 years of the study. Grooming was more important in the second year, while flying was more important in the first year. Finally, the multivariate analysis of 3 wintering seasons and identified 3 distinct periods in the animal cycle. The first period, from September to October, is the start of the wintering, marked by frequent short flights, triggered by repositioning or disturbance. The second period, from November to January, represents peak wintering, characterized by high sleeping activity combined with morning and evening grooming to maintain the plumage and feathers after migration. The third period, from February to April, is the pre-breeding phase, dominated by feeding and swimming, along with the beginning of pair formation and some low-level parade behavior as the bird transitions from gregarious group to smaller breeding units. So this is a recapitulative and resume of all species where were studied and to locate them. So the mallard was studied in the northeast in the Lake Tonga, as well as the Ferruginous duck, which were studied in 5 sites. So Lake Tonga, Garat Hesh Tahar, Lake Suzara, Kadamash, and Lac des Oiseaux. As for the white-headed duck, which was studied in highlands, so Bugazoo, Garat ولاد عمارة, Bugazoo and Bugaradam, Shot al-Hudna, and Garat ولاد عمارة. So for the marble teal, which were studied in Shot Umarranem, as well as the greater flamingo, plus El Golia Lake. So moving on to the effect of abiotic factors on water birds. So this part of the study was conducted in 4 wetlands, 2 coastal areas, and 2 highland areas. So the 2 coastal areas were Boussada Marsh, Mikada Marsh, and the 2 highland areas. Wetlands were Sibkhat Bazar Sikra and Shot Gedei. So, analysis of physical-chemical and bacteriological parameters across 4 wetlands revealed significant spatial variation. Shot Gedei exhibited high electrical conductivity and mineralization linked to geological and hydrogeological factors, such as evaporation and water-rock interaction. Turbidity was highest at Garat Hesh Tahar, likely due to biological activities or sediments. Nutrient level, such as phosphate and nitrates, varied notably, influenced by agricultural runoff, while ammonium concentrations were elevated at Boussada Marsh, indicating an organic pollution. Bacterial contamination varied with proximity to urban or agricultural areas. So, we will start with the figure, the 59th figure, A, wintering. So 4 of 5 waterbird species were present year-round in all sites, with greater flamingo only found in highlands, White-headed duck and ferruginous duck were more abundant in coastal wetlands, while marbled teal favored highlands. Flamingos were more common in high plains, but absent from coastal area due to habitat preference. All species peaked in winter and declined sharply in spring and summer. Mallard were the most abundant species, particularly at Garat Hashtar. We move on to the second part, breeding. So, nesting occurred for all species except for greater flamingo, with mallard and ferruginous duck having the most active nest, while white-headed duck nested mostly in coastal area, but was also notably in highlands, while marbled teal nests were rare. So we move to the last figure. So the BCI of physical chemical parameters and bird abundances explain only 60.1% of the variation across 4 wetlands. So the first axis, which represents 31.5%, separated Subkhat Bazar Sikra, characterized by higher conductivity, ammonium and fecal streptococcus from Garat Hashtar and Shot Gadayin, which were associated with white-headed duck, while the second axis, which only explained 28.6%, reflected positive correlation with greater flamingo, marbled teal, mallard, ferruginous duck, as well as nitrate, nitrate, and organic matter, distinguishing Subkhat Bazar Sikra from Busdra marsh, while Garat Hashtar resembled Busidra and Shot Gadain showed overlap with all the sites. So, to resume again, so Subkhat Bazar Sikra was strongly associated with ammonium, electroconductivity, organic matter, nitrates, and fecal streptococcus, which mean more atrophic or polluted water condition, which was also linked to flamingos. Busidra marsh showed weak association with any extreme parameters, likely moderate water quality. Shot Gadain was associated with ferruginous duck, mallard, and marbled teal, and was also linked with a higher percentage of nitrates. Garat Hashtar was associated with white-headed duck, slightly separated from other species, suggesting the specific conditions favoring these species. Now we move on to the findings and discussion. So, for greater flamingo, Shotomaranab and Lake Ilgolia are confirmed as major winter habitats for greater flamingo. Peaks observed for about 7,500 individuals at Shotomaranab, which corresponds with polyrexic migration routes. Feeding was the dominant activity, and other activities were less than 2%. So there is a weak positive correlation between feeding and walking, and a strong negative correlation between walking and flying. And there's a distribution. The distribution is influenced by water depth, physical chemical quality, and bacteriological parameters. As for the mallard, the maximum numbers were observed in December 2021. In November 2022 and December 2020. The minimum was recorded in June, with absence in July and August due to the lake drying up. Presence throughout most of the lake, often in small groups with preference for area rich in ilophytes. Feeding was the most dominant activities, while resting and sleeping came next. Swimming third was relatively stable, and grooming and flying was represented in low percents. So, special features. In September-October, there was a higher proportion of swimming and grooming linked to post-nuptial molt and gatherings. 3D snakes phases is identified. So, in September, there's intensive swimming for aggregation. In October, it's for grooming and short flights for after migration, and from November to June, which was dominated by feeding and sleeping. As for the ferruginous duck, so we counted approximately 790 individuals recorded in five coastal wetlands from 2021 to 2023. which was one of the most abundant species in the study sites. Diurnal activity dominated by sleeping, while feeding, swimming, and grooming were to a less extent. Aggressive or display behavior were very rare. Preference for deep, calm areas rich in trophic resources, while the multivariate analysis showed a strong influence of physical-chemical parameters, nitrate, nitrates, and organic matter on depth and local abundance. This contrasts with this decline observed in Europe and Asia, which means that the role of Algerian wetlands as a refuge for these species is classified as near threatened. Fourthly, moving on to the white-headed duck, so fluctuations between 50 and 200 individuals in 5 wetlands studied, so highly significant difference in abundance between sites. Low seasonal variability where sleeping remained the dominant behavior except at Bugara Dam, which was feeding. Clear preference for deep areas away from disturbances, favoring calm and food availability. Distribution is also influenced by water depth, physical-chemical quality, and bacteriological parameters, and higher abundance in sites combining good water quality and adequate depth. So, lastly, the marble teal, which showed a regular but modest presence at Chota Marana. Numbers varied from 11 to 212 during the first year, from 43 to 240 in the second year, and from 63 to 215 in the last year. Seasonal peaks reached in October, almost every year, and activity dominated by feeding, while other activities are in smaller proportions. Affinity for intermediate size, shallow body of water with moderate vegetation and marshy areas, and the distribution is influenced by water depth, physical-chemical quality, and bacteriological parameters. Lastly, we will discuss the effect of abiotic factors on waterfall. So, the study showed significant variations in physical-chemical and bacteriological parameters among the 4 sites studied, with a marked gradient in electrical conductivity and higher mineralization at Shotgadayan. This aligns with the geological and hydrological factors influencing water chemistry in Algerian wetlands. Nutrient level shows phosphate and nitrate shows, such as phosphate and nitrate shows significant spatial variation, possibly related to agricultural activity, while ammonium was particularly high in Boussodra marsh, indicating an organic pollution. Bacteriological contamination was notable, with high level of fecal streptococci and coliform linked to proximity to urban or agricultural areas, demonstrating anthropogenic impact on water quality. The variability in water quality parameters suggests distinct ecological niches among the wetland, influencing avian species composition. Temporal bird abundance patterns showed that greater flamingo was mainly abundant in high interior plains, where wetlands with larger brackish and saline habitats, while white-headed duck and ferruginous duck were more abundant in freshwater coastal wetlands with dense emergent vegetation. So the marble teals were more found in high plain wetlands, correlating with semi-arid and arid environments. Nest monitoring showed breeding activities for all the studied species, except for greater flamingo with mallard and ferruginous duck having the highest number of active nests, while white-headed duck nested were more found in coastal sites, but were also present in the highlands. The PCA revealed how wetlands differ in water quality and how this shapes bird communities. Trophic and impacted waters with high nutrients, organic matter, and fecal bacteria were more linked to flamingo, while certain wetlands show distinct niches. Example for white-headed duck, which prefers Garad Hashtar. Now we move to the conclusions. So, the 5 bird studies, so Phenicopterus roseus, Aetioneruca, Oxyuralocoscephala, Mammalita, Angustirostes, and Anaspatericus are sedentary breeding species with wintering population are more substantial, and the highest numbers were recorded during the wintering season. The Anatidae generally occupies the center of the water body, and the Phenicopteridae are distributed over the entire body of waterland. The study of diurnal time budget showed that our wetlands play a dual role for these species. So the first role as a diurnal feeding ground for greater flamingo, for the marble teal, and for the mallard, and a diurnal staging ground for Ferruginous duck and the white-headed duck. And finally, anthropogenic pressures like urbanization and habitat degradation are increasing, demanding targeted conservation strategies and the integration of behavioral and abiotic data into management plans. So this work was valorized by publication of 3 international papers and participating with 2 international seminars and 2 national seminars. Lastly, I would like to warmly thank these persons. So firstly, I would like to warmly thank my supervisor, Professor Bara, and my father, Professor Mustafa Hamdi, for their support throughout this journey. Secondly, I would like to warmly thank my other supervisor, Professor Juan Manuel Perez Garcia, and his team for their support. Thirdly, I would like to thank my mother for her support and emotional throughout this journey. And finally, I would like to thank you. And thank you for your attention.